and welcome viewers to the Daily Space Weather. We're looking at the sun here from the Solar Dynamics Observatory in 3 wavelengths. 2 ionized iron emission spectra, that's 211 and 171 angstroms, as well as 304 angstroms, which is ionized helium. We see a possible coronal mass ejection kicking off right here at the end of the browse data video, right there. From a non-sunspot region, it's just an active plage. And regarding our title, we knew what we were getting into when we started covering the sun at solar minimum. We need your assistance before we get to solar maximum. We need things like views and shares. Please tell your friends and foes about our channel. And congratulations on finding it yourselves, by the way. And we've seen some changes happening with our sunspot groups. Let's break it down. Sunspot 2837 up here is very simple. It's an alpha class sunspot. It only has one polarity, umbra. Sunspot 2836 down here has degraded a little bit here over the past 24 hours. And sunspot 2835 has grown in its leading umbra. So this one right under my pointer right here, that umbra right there has gotten a little bit bigger. Otherwise, we've seen a mostly degradation here. The likelihood of solar flare still does exist. However, the Earth-facing quiet is about to come into effect. So for the next couple of days, we can expect lower X-ray output, assuming we don't see any new sunspots. But all things remaining the same, we can expect lower X-ray output as a result of the Earth-facing quiet. Here's a diagram of the solar system. We'll advance this 1 week. There's where things will be on July 6th. Here's a star chart. If you're up before dawn, you may see Jupiter, Saturn, and the moon up there. I think that's the moon. And that's Jupiter. And that's Saturn. I use in-the-sky.org. This yellow line is the ecliptic, the path the sun will take across the sky. And back to the sun, the radial flux is currently at 89 solar flux units. Here's a 1-year chart of that to put it in context, and we're finally seeing a little ramp up here, both in sunspot number and in the radial flux. This black line is the radial flux, the red line is the sunspot number, 2 proportional aspects of solar activity. No geomagnetic storms forecasted by NOAA in the coming days. We do see an earthquake lull. Let's take a look at seismicity in detail. Here's the 90-day bar graph, and you can see how few 7-magnitude earthquakes we've seen in the past 90 days. Here are previous years, and you can see how many red bars. It's an earthquake drought. If you're in an earthquake-prone zone, please have a plan. Here are the 4-magnitude earthquakes, and there are only a couple of 5 magnitudes here, northern Oceania, in the past couple of days, and in the past day, rather, the past 24 hours. And we're just going to scroll up the list here. There was a 5.3 at Japan. Southeast of Japan in the ocean, actually. And we're just going to continue up the list here. If we leave anything out, please leave us a comment. We consider the videos a collaborative effort. Yet another reason why we need you, the viewer. Deep quake in Chile at a 4.3 magnitude. Vanuatu saw a nearly 100-kilometer deep quake at a 4.8. So yeah, significant earthquake lull here, folks. Know which building facades may collapse if you have to evacuate your location. Have a bug-out bag. Tell your friends and foes that we're seeing an earthquake drought. Here's another deep quake at Vanuatu. That was a 5.3. Argentina also saw a 4.6 at 127 kilometers. Puerto Rico saw a small quake at exactly 100 kilometers estimated depth. Japan saw a 5.0. Continuing on to volcanoes, we see some new additions to the list here and some pretty extreme activity. Sakurajima, starting the list out there with a flight level of 070 as it produces a 7,000-foot ash plume. Suwanosejima exploded. Unknown volcanic ash plume size there. Now, Tal in the Philippines on the Isle of Luzon has been degassing and producing intense sulfur dioxide emissions, reaching 14,000 plus tons per day, which is almost 5 times the average level over the past 2 months. So gas plumes rising from the crater lake, which rose to about 8,000 feet of altitude. Mount Merapi, flight level 120, it's a 12,000 foot ash plume there. Semeru, 14,000 foot ash plume as it explodes over East Java, Indonesia. Tocono exploding, flight level 070, it's a 7,000 foot ash plume. Rincon de la Vieja on Costa Rica, now producing a phreatic explosive eruption. Flight level 130, it's a nearly 13,000 foot ash plume over the Costa Rican Rincon de la Vieja volcano. Sangay also probably erupting, although volcanic ash not seen in satellite. It's probably because it's cloudy. Revenador exploding, also in the same country there of Ecuador. 15,000 foot ash plume there. And Sabancaya exploding, producing 24,000 foot ash plume. Please don't pole vault the caldera. It could be unhealthful. And again, we need the views on YouTube. So please press share. Tell your friends and foes about the channel. Nobody else is doing it or able to forecast coronal mass ejections before they exit the solar corona, except us. So here we are. Please help us out. Here's the GOES X-ray flux over the past 3 days. And we're probably going to see this get a little bit milder here, as there are several active regions about to move into a directly Earth-facing orientation, which reduces the amount of X-ray flux. We won't get into the physics of it here, as that's for a cosmology segment. Proton flux showing no spikes, no coronal mass ejections headed our way. No surprises there to our regular viewers. Next, looking at the heliospheric current sheet, and we're seeing some changes here. It's a battle between the North and South Pole current sheets. So if we bring up the last image and we bring it back a couple frames here, you'll see the South Pole there, and then the North Pole snapping through. So the Earth is quite close to a heliospheric current sheet polarity boundary crossing, and it could suddenly snap across. Keep in mind, this data is 1 hour and 41 minutes old from when we made the video, and the magnetic environment can change with absolutely no warning. Anyway, that's the data on that. Here's the line of sight view of the same data essentially, and you'll see this blue line here rapidly swirling around. That's the sun's B field being affected by coronal holes as well as sunspots. Here are the coronal hole line of sight field, line of sight coronal hole plot here, also showing you the sun's B field in blue, and you see some sudden changes here as we see coronal holes opening up just northeast of sunspots 2835 and sunspots 2836. So right up here, we're seeing some new coronal holes popping up there. They're just about to the trans-equatorial zone there, and those may become geo-effective if they remain as organized as they currently are. So you're not going to see them pop up here in the detected coronal holes imagery yet. They're sort of over here, and there's a bunch of plasma in between the Earth and those coronal holes. They're only showing up in magnetometer data right now. And here's some more magnetometer data, and you can see these are both beta-gamma class sunspots. And while they do harbor the capacity to produce significant solar flares, again, the likelihood of major ones detectable from Earth are a little bit lower. Sunspot 2837, pretty unexciting there. It's an alpha class sunspot with only one polarity, umbra. Planetary KP index at 0, and we're going to take a look at cosmic rays during the cosmology segment today, so make sure you tune into that. If you haven't, it'll be a separate video. Moving on to the real-time solar wind to see pretty uneventful stuff here as well. Very slow speed here. 318 kilometers per second is the solar wind speed, quite slow. And pretty diffuse here as well. The density only 4.46 protons per cubic centimeter. Here's a magnetosphere movie, 4 hours of data showing magnetohydrodynamic pressure according to the Space Weather Modeling Framework. And we see massive plasma spheres there. Those empty spaces, those are what you call the plasmasphere. That's sort of the magnetic backwater where a bunch of ionized particles get trapped within the Earth's Van Allen belts, which are looking pretty weak right now as a result of that low speed and low density solar wind. Now looking at ground magnetic perturbations here, changes to Earth's own B field. Ground magnetic perturbations, otherwise known as geospace delta B, changes to Earth's B field. No major variations happening here, I don't think. Again, this is 4 hours of data. And both of these magnetosphere movies are courtesy of University of Michigan. So we just recorded a cosmology segment, folks. We hope you tune into that. It'll be a separate video. Let's get back to local environment type stuff. No charging hazards around planet Earth right now caused by electron flux. Here's the 1-year graph of the electron flux, and we're just in moderate to low levels here. Here's a 3-day chart. Just moderate to low levels, nothing to write home about there. How about the total electron content forecast? Here's the relativistic electron forecast model. The green boxes are the forecast. Again, low to moderate levels. And here's the total electron content visualization showing you electron density for the entire air column. Up to tens of thousands of miles of altitude to where your GPS satellite's located. And it's pretty good at showing the locations of GPS errors there, the total electron content forecast. And there's a diagram of the Van Allen belts and so on to help you visualize what you were just looking at. And here's another visualization. It's the F ionosphere layer animation. So the F ionosphere layer located at about 300 kilometers of altitude. It's one slice, and we're seeing vast anomalies happen once again in the ionosphere. Surprisingly high vibrational frequency here over the South Central Pacific, as well as some wild swings from low vibration to high vibration modes. Each blob here representing 1 megahertz of resolution. So some anomalies happening here. Once again, back to a more anomalous mode of the ionosphere. Here's the latest image from 8 o'clock Universal Time. And here come our daily space weather bonus features. We're starting out with the El Teide Observatory. It's the El Teide, Spain, ground-based solar observatory. We still do have filaments. We still could see coronal mass ejections. We can see filaments up here. We can see filaments down here and filaments over here, around where those coronal holes have recently opened up. So there's your latest data from your ground-based National Sunspot Observatory. Here is your thematic map from the GOES 16 SUVI. Lots of filaments between the Earth and the Sun right now. Coronal mass ejection watch is still in effect, although most of the plasma has already ejected. There still is a significant possibility for additional coronal mass ejections. Likelihood of major solar flares has gone down a little bit as the Earth-facing quiet will come into effect. Here's the latest imagery of sunspot 2835 and 2836, and you can see sunspot 2835 remains quite complex. This is a South Pole umbra. This is a North Pole umbra. Sunspot 2836, this smaller one down here, has degraded a little bit, especially in its trailing umbrae. And there's sunspot 2837, still pretty basic here. Only one polarity umbra there. So you can see that only one umbra, and that is a North Pole umbra there. And last but not least, here's some imagery of the closest star in 193 angstroms, ionized iron, from the Solar Dynamics Observatory. Certainly looks like a coronal mass ejection could be happening as we make the video here. Right at the end, you're going to see a little pulse come out of this area. Whether that collapsed back onto the chromosphere, stayed in the corona, or ejected is up for debate, as it's too early to know. In any case, thanks for tuning in to the Daily Space Weather. I've been your host, Dan, a.k.a. smAsho. Wishing that solar wind be at your back.